For each of the following graphs of polynomial functions, determine the number of turning points, the number of x-intercepts, the sign of the leading term, and the minimum degree of the polynomial. Well, let's start off with part A. Determine the number of turning points. What we need to recall is that a turning point is a place where the graph changes from decreasing to increasing, or vice versa. The turning points correspond with the valleys and the peaks of the graph. Graph A has one valley and one peak, therefore it has two turning points. The valley is where the graph changes from decreasing to increasing, and the peak is where the graph changes from increasing to decreasing. Graph B has two peaks and one valley, therefore it has three turning points. Graph C has two peaks and two valleys, therefore it has four turning points. For part B, we're asked to determine the number of x-intercepts. The x-intercepts occur when the graph intersects the x-axis. Graph A intersects the x-axis twice, so it has two x-intercepts. Graph B also has two x-intercepts. Graph C intersects the x-axis 5 times and therefore has 5 x-intercepts. For part C, we're asked to determine the sign of the leading term. To answer this question, we need to recall the form of a polynomial function. A polynomial of degree n has the form f of x is equal to a sub n x to the n plus dot 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 plus a sub 2 x squared plus a sub 1 x plus a sub 0. The coefficients, the a values, are real numbers, and the leading coefficient a sub n cannot be equal to 0. The degree of the polynomial n is a non-negative integer. The leading term of the polynomial function is a sub n x to the n. To determine the sign of the leading term, we can look at the right n behavior of the function. For graph A, we see that as x increases without boundary, the function decreases without boundary. Therefore, as x goes to infinity, f of x goes to minus infinity. Now let's think about what happens as x goes to infinity in our equation. As x goes to infinity, the leading term will dominate. In other words, its absolute value is going to become much larger than the absolute value of the sum of the remaining terms. Therefore, to determine the sign of the leading term, all we really need to do is just investigate the leading term. We know that x is going to positive infinity. When we raise positive numbers to a power, the result is a positive number. We then need to take that positive number and multiply it by the leading coefficient. If the leading coefficient is positive, the end result will be positive. If the leading coefficient is negative, then the end result will be negative. So in this case, we've determined that f of x is going to minus infinity. That means that if we substitute in a large positive value of x, the end result is going to be negative. Therefore, the leading coefficient must be negative. For graph B, we also see that as x goes to infinity, the function decreases without boundary. Therefore, the sign of the leading term for graph B is also negative. For graph C, we see that as x increases without boundary, the values of the function also increase without boundary. In order for that to happen, the sign of the leading term must be positive. For part D, we're asked to determine the minimum degree of the polynomial. So let's recall the relationship between the degree the number of x-intercepts and the number of turning points for a polynomial function. We recall that the graph of a polynomial function of degree n with n greater than or equal to 1 has at most n x-intercepts and at most n minus 1 turning points. From this, we can deduce that the degree is at least the number of x-intercepts and at least one more than the number of turning points. So let's look at graph A. We've determined that the number of turning points is 2. Therefore, the degree must be at least 3. The number of x-intercepts is 2. Therefore, the degree must be at least 2. Since the degree has to be at least 3 and at least 2, we take the larger of these two values as the minimum degree of the polynomial. For graph B, the number of turning points is 3. Therefore, the degree of the polynomial has to be at least 4. The number of x-intercepts is 2, so the degree has to be at least 2. Since 4 is the larger of these two values, the minimum degree of the polynomial is 4. For graph C, the number of turning points is 4, therefore the degree of the polynomial must be at least 5. The number of x-intercepts is 5, so the degree of the polynomial once again must be at least 5. In this case, both the numbers are the same, so the minimum degree of the polynomial is 5.